Hey everyone, today we're going to be learning about different types of chemical reactions. So the first type that we'll cover here is called a synthesis reaction. So any synthesis reaction is going to have two or more reactants. So again, the reactants are what's on the left side of a chemical equation. So A and B would both be reactants and they come together to make one product. So we started with two reactants and we made one product. So synthesis is just two or more things coming together to make a singular product. And in this case, A and B are placeholders for actual elements. So to give you a real example, if we take hydrogen gas, so hydrogen plus oxygen makes water. So we're creating one unified product from two separate elements. Right. So the next type of reaction we can have is just the opposite of synthesis. So decomposition. We're starting with a compound, so AB would be like our compound we're starting with, and it breaks down into A and B as separate elements. So in this case, we're starting with NaCl as a compound, and NaCl breaks down into chlorine and sodium. So we would call that a decomposition reaction because my compound is decomposing into smaller parts. This will be the opposite in the sense that you'll start with one reactant and it's going to break down into multiple products. So we start with one reactant, and in this case we have two products. A single displacement reaction is when you have one element all by itself and it's going to replace another element in a compound. So if A is the element all by itself, it's going to kick out B, and then in your products B will be all by itself and A will be bonded to C. So you always start with one thing by itself, and then that one thing that started by itself ends up bonded, and the other thing is going to be on its own. Just to show you an actual example of what this looks like, if we have aluminum, so if we react aluminum, which is all by itself, with copper chloride, aluminum is going to kick out copper, and now copper is by itself. So what that looks like in the actual reaction, we have aluminum all by itself right here, the aluminum foil. It reacts with copper chloride, and when that happens, aluminum now bonds with chlorine, and we have aluminum chloride, and then copper is all by itself. So what that looks like is on the bottom of the beaker, you have all this copper that's all on its own. Next type of reaction we can have is double displacement. So this is where you have two compounds together, so you're not going to have any elements that are on their own. So we have AB as a compound, CD is also a compound, and A and C are just going to switch places. And then when that happens, C and B will bond together and A and D will bond together. So a couple of examples of what this looks like. If you have KBr plus AgNO3, so NO3 is nitrate. So potassium is going to switch places with silver. Silver is going to swap over here. Now you have silver bonded to bromine, and then you have potassium bonded to nitrate. Another example, if we have NaCl and AgNO3, Na is going to switch places with Ag. They just swap places. When that happens, Na will now bond with NO3, and now we have Ag bonded with Cl. So they're just switching partners. The last type of reaction that we'll talk about today is called a combustion reaction. So a combustion reaction just means something is reacting with oxygen and burning. So a couple things that all combustion reactions have in common is on the reactant side, you're going to start with a hydrocarbon, so carbon and hydrogen reacting with oxygen to create H2O and CO2. So if you've ever put a lid over a candle, the candle goes out. So a candle burning is a combustion reaction. In order for that reaction to actually work, it needs to be reacting with oxygen. So if you put the lid over the candle, it suddenly doesn't have any oxygen to react with, and the reaction can no longer continue. So just to show you an example of this is a Bunsen burner that we use in class. So the reaction that's going on in the Bunsen burner, you have CH4, which is methane, reacting with oxygen, and that's going to create CO2 and water. So those two products will always be made in this reaction. So every combustion reaction is going to look very similar in that it's some amount of carbons with some amount of hydrogen reacting with O2 to create water and carbon dioxide.